Our next speaker this morning is Dan McPherson. He's going to be speaking about ovirt and then Aeolus. Is that how you pronounce it?
Ovirt and Aeolus, yeah.
Okay, right, thank
you. Can you? Is this on? Is this on?
Yep, that's working.
Okay. Can we? Do you want to use this?
Exceed the potential of commercial products, commercial closed source products. And that's why I believe that we're gathered here at this particular mini-conf, because we're approaching a new era, if you will, of open source cloud computing and virtualization technologies that rival commercial offerings such from VMware and Microsoft. So I'm here today to talk about one of those technologies, which is ovirt. It's an open source KVM virtualization platform, and it's built as an open source alternative to vSphere. It's the upstream model that we use at Red Hat for Red Hat Enterprise Virtualization. Yeah, I might want to do that as well. Gone, okay. Okay, just a little bit about me as well. I've been working with virtualization technologies for the last 6 years, including VMware, Xen, KVM systems, and for the last 2 years I've worked with Red Hat as a technical writer for the cloud and virtualization products. I've been writing for ovirt Rev for about the last year and a half. My favorite part, which I'll get to, is the API. It's a REST-based API, and I find it very clean and easy to use, so more on that later. So what is ovirt? Large-scale centralized management server, desktop virtualization system. So it's easily scalable and provides, as I said, an open source alternative to vSphere, vCenter. A little bit about the community. So the ovirt community is an open merit-based governance model inspired by both Apache and the Eclipse foundations. Now the ovirt board consists of members from Red Hat, SUSE, Canonical, Intel, NetApp, IBM, and Cisco. And as well as the board, we've got the ovirt project is divided into several different sub-projects, currently 16 of them. So we've got some key goals. So to build a community around all levels of the virtualization stack, so the hypervisor manager, the GUI, the API, to deliver both a cohesive, complete stack and discretely reusable components for open virtualization management. To provide a release for the project on a well-defined schedule, so 6 months. Focus on management of the KVM hypervisor with exceptional guest support beyond Linux, and provide a venue for user and developer communication and coordination. We're also always on the lookout for people to join our teams, especially in the areas of development, design, testing, documentation, and translation. I'll go a bit into the architecture now. So ovirt, an ovirt environment consists of 3 main components. So you've got the ovirt engine, which is the management component. You've got ovirt node, which acts as the hypervisor, and you also require storage for virtual hard disks and ISOs. So I'll discuss each of these components individually. So starting with ovirt. So it's a JBoss Java application used to communicate with hosts and to manage the entire virtual machine lifecycle, including deployment, starting, stopping, migrating, and monitoring of virtual machines. It provides several methods for interacting with your environment. So you've got the web admin portal, web-based UI application on top of the engine. Sysadmins can use it to perform the advanced actions. There's also a self-service user portal, simplified web-based UI, just for simpler management use cases. You've also got a REST API, which allows third-party applications to perform virtualization actions. There's also a software development kit, which provides Python bindings for the API, and a command line shell, which communicates with the engine via the software development kit, and you can use line commands and script actions to control your environment. So here's a couple of screenshots. So what we have here is the main administration console. A couple of screens here, so creating a new host or adding a new host to your environment. You can also set power management features as well. Setting up networks as well. This uses a drag and drop interface to be able to bond and attach your interfaces to networks. So for example, here's bonding in action. Sorry for the quality of the video there. Might not be able to read some of the options there. Then you can edit your bond and attaching to a network, a logical network. Just as simple as drag and drop. Creating a new server or desktop. So you've got the base information there, memory size, how many vCPUs, which operating system that you're using. You can also specify which, these are actually for Windows VMs, so you've got your sysprep configuration there for time zone and also domain. You've also got support for USB and smart card as well, plus also the two different remote access protocols, so you've got SPICE and VNC. Host aspects, so you can choose to run on a specific host or you can let ovirt manage that directly. You've also got migration options there and CPU pinning, so you can choose for a specific core in your host. Also high availability. You can also set pre-allocated memory, so maximum or the minimum amount of memory guaranteed, as opposed to the maximum memory that you set in general settings. So if a VM is not as resource intensive at a specific time, it saves that memory for other VMs to use. Can define the boot sequence, and also you've got custom properties. So this is based on, the custom properties are based on the hooks, which I'll get into for the hypervisor. So you've got a simplified version of the user portal, and also an extended version. So allows you to actually define virtual hard disks and also your network interfaces. The REST API, so I find it, like I said, I find it very easy to navigate through. Basically, you've got all your virtual resources as collections, and to navigate them, like for example, to navigate to a particular host, and then sub-collections based upon that, so you can look at the host network interface and see the information there. Ovirt node, this is the second component, so we've got two versions. So there's the standalone hypervisor, which a very small distribution, a custom spin of Fedora, and it uses just enough Fedora to run on the machine. So it runs on any RHEL hardware, Fedora. And as an alternative to ovirt node, you can also use a full host. So for example, you can use a Fedora host and install VDSM and libvirt to act as a hypervisor. So key aspects, you've got configuration of hosts, networking and shared storage. It uses libvirt for the VM lifecycle operations, multi-threaded, multi-process. It uses virt.io serial to communicate with the guest agents. You've got customized clustering support for logical volume management, and it scales to hundreds of nodes. Implements distributed image repository over the supported storage types. And you've also got a multi-host system with one concurrent metadata writer. As I also mentioned, there's a hooks mechanism for ovirt node, so this allows you to add your own scripts and modify VM operations. So they're called specific events. So this gives you an opportunity, so let's just say, for example, there's a new feature in KVM that's not in ovirt as yet. You can create a script to be able to make use of that particular feature. And also you've got storage as well. So ovirt includes support for several file and block storage methods. So you've got local storage on the actual hosts themselves. You've got NFS, you've got iSCSI, you've got fiber channel and POSIX storage, such as Gluster. So these storage domains provide a means to store disk images for virtual machines, storage for exported virtual machines, and ISO images for installation media. And the data storage domains for the virtual machines also support copy on write and raw formats for creating the disk images. Some key features, so scalability, you can easily create and attach as many ovirt nodes to your environment to increase virtual machine resources. High availability, so if a host fails, you can restart a VM on another host. You can restart its VMs on another host, sorry. You've also got host live migration, so you can move running VMs between hosts without any downtime. Storage live migration, so you're able to move running VMs from one storage domain to another. So say, for example, you've got virtual machines on an NFS, and you want to move them, you've set up a data domain for on a block storage on iSCSI, you can easily migrate the virtual machines from one data domain to another without any loss without any downtime. You've also got network filtering, so you've got control over your network traffic as well. Port mirroring, so the ability to mirror network traffic to a specific VM. Image management, so template-based provisioning, thin provisioning and snapshots. On the snapshots, you've got live snapshots, so you can easily take a snapshot of a VM on a running VM without any downtime. Direct LUN support, so you're able to attach block devices as volumes directly to the virtual machines as well. You've got shared and floating disks, so you can hot plug disks between several virtual machines. Just as long as it's not a system disk, you can actually share disks in between virtual machines. You've got system scheduler, so this allows you to load balance your VMs based upon resources and resource usage and policies. There's a power saver, so ovirt focuses your virtual machines on fewer hosts during off-peak times. So in addition, ovirt provides you with options to control your host power management operations, as I showed before. You've got a maintenance manager, so if you need to patch a hypervisor, you can do so without any downtime by just setting maintenance windows. You've also got monitoring tools, so these are system status. These show the system status for all objects in the environment, so if your VMs, your host, your networking, your storage, your clusters, your data centers. A new feature, SLA MOM, it's a policy engine. I'll just skip to the next slide because there we go. So this helps with a policy engine to help with memory management. You've got a data warehouse and reports, so it uses a customized Jasper reports and Jasper server to provide high-level reports about your virtual environment over set periods of time. You've got OVF import and export, so you're able to import and export VMs using open virtualization format files. V2V and P2V tools, so you can convert physical servers or VMs from VMware and Xen to KVM. You've got two different protocols there. You've got VNC and you've also got SPICE protocol. USB and smart card support, so you're able to pass through client-attached USB and smart cards to virtual machines. A new feature for the next release is Gluster management support, so it features the ability to manage your Gluster storage volumes and bricks and integrate them with your virtual environment. The API, as mentioned, ovirt contains a REST API using standard HTTP protocols to control and monitor all resources in your virtual environment. The API also defines capabilities for previous versions to help with backwards compatibility. And as I mentioned, there's also Python-based software development kit as well, and command line, as well as command line tools and scripting shell, plus UI plugin support. And I'll go into a bit more detail about UI plugin support because this is a relatively new feature. So what the UI plugins do is allow you to extend the web admin. Plugins are written in JavaScript and invoked on runtime, plus they're also invoked the moment of certain events. So for example, when a user logs in or say a particular action, you click on a particular menu item. To give you an example plugin, this is a basic Hello World example. So you use your configuration file to define your plugin. And then you've got the host page, which allows you to actually write the plugin and integrate it within the web UI. So like I said, this is just a simple plugin that displays a window that says Hello World. There's full documentation on the ovirt website, plus there's samples as well. So there's a Foreman plugin, so it provides info on Foreman-related entities such as VMs. You're able to see the lifecycle and monitor your VMs using Foreman and have that integrated directly into ovirt. And then you've also got Shell in a Box, which provides SSH connections to hosts, and shell emulation with the UI. So say, for example, you need to do some host maintenance, you can do that directly through ovirt with this particular plugin. Getting ovirt, so you can obtain it from the ovirt website. There's two methods. We've got our official packages, plus there's also a live USB, which is probably the easiest method to get ovirt engine. So basically that's just live USB, plug it in, boot on USB, and you've pretty much got ovirt engine, and you can start attaching nodes straight away. You can build from source, and there's also the Fedora repositories, which are at the moment at ovirt 3.1, our current version, I think, which is being released. I'm not too sure if it's released now or if it's being released in the next couple of weeks, but the current one, the Fedora repositories, are ovirt 3.1. How to contribute and download. So you've got the website and the repository, and we've got our mailing list, and we've got an IRC channel as well. And that concludes my talk on ovirt. Are there any questions? Yep.
Is it possible to cluster the management node, the ovirt engine, or is it a single point of failure?
Say that again. What was that last bit? Yes. Yep. So.
Using some solution like clustering services, or is it built in?
It's built in. Yep. Any other questions? Yep, up the back in the red shirt. No. Not that I know of. Not that I know of either. Yep.
Is there anything magical about the way that the management server talks to the nodes that we couldn't replicate?
That you couldn't replicate?
So would it be possible if we decided to have support for the nodes?
Quite possibly, yeah. I mean, it's basically, the nodes are basically using VDSM and libvirt for control, so I don't see any problem being able to integrate that within CloudTech. Yeah.
Because I saw a presentation about that. It's kind of like, it's basically like Zen server XCP for KVM, so I don't see why we shouldn't.
Pretty much, yeah. Yep, up the back.
How do you manage the connection between VMs and hot pluggable devices?
I'm not exactly sure. All I can really say is they found a way. But yeah, apparently there's a queuing mechanism for being able to write. But yeah, apparently, yes, you can share devices between two running VMs, storage devices between two running VMs, and you can hot plug and unplug, and yeah. Yo.
What's the relationship between ovirt and the Red Hat OpenStack in Red Hat Cloud portfolio? Is there any plan to somehow merge these two?
With OpenStack?
Yeah. Red Hat has recently released Red Hat OpenStack distribution, right? And at the same time, there is RAS/ovirt.
Yeah.
I'm wondering if Red Hat has a long-term strategy of combining these two somehow.
Not that I know of, no. But basically, from what I understand, they're two, I guess, cloud products for two specific purposes. They share similar functionality, but I guess the differences depend more on the feature set in that case. So I guess there's some distinction between the two. Yep.
What would you say, so I kind of wondered this at the content, there seems to be a lot of overlap. There's obviously some differences in each. So what would you say the workload expectation is for
I guess it depends, like I said, on feature set, like with ovirt. And this is the thing, this also, it's hard for me to comment because I've got a very limited knowledge of OpenStack as well. I've used it and I'm not too sure about the architectural underlyings. But I guess if I had to sort of pin something, it would be specific feature sets for both. I don't know if I can be any more specific on that, but yeah, I guess it's sort of more, I guess ovirt, you sort of be looking more for enterprise style. Yep.
I was just going to say, ovirt is really targeted at your typical VMware management guy, the guy who usually has VMware at ESX running, whereas the OpenStack distribution is really targeted at really large scale-out cloud deployments. So right now those are different enough. Eventually they may converge, but those are the two buckets.
So what about enterprises that are in the middle of doing both?
That's a great question. We'll see how that shakes out.
In the middle? Oh.
Just to come back to Joe's comment and the comment over there.
Yep.
The whole thing with ovirt is the API layer, the full RESTful API.
Mm-hmm.
So one of the aims with Red Hat is that ovirt or Red can be a platform for OpenStack to target. There's no reason why it also could be a platform for other cloud platforms to target and for the ovirt engine to manage.
Absolutely, and I'll get into that in a minute with my next talk, which is on ELIS, which does exactly that. So being able to integrate, OpenStack support through to ovirt. Yep.
Question for you, maybe as much as for John Mark. Using BusterFS as a storage backend
Mm-hmm.
in conjunction with live migration, is that a performance issue? Because QEMU has these things with you can't use caching if you want to be able to live migrate.
Mm-hmm.
Does that apply here as well? So.
Hang on, let me take this.
Yeah.
Eventually, there are patches that are currently under review which will bypass QEMU.
Yeah.
And so that make use of the recent KVM integration work that we've done to let you do that.
With libcapacity.
Yes. Yeah. Exactly. So that's kind of that's under review right now, but it should be in the main branch.
And does libcapacity actually have a caching layer?
I don't, not at this point. I don't think so, but no reason why.
Okay, any more questions? Oh, yep. I'll go up the back there, yep. Not really a replacement for Virt Manager. Virt Manager, I guess, is for more simple use cases, whereas this is more for large scaling and for being able to run virtual machines without any downtime. So to be able to live migrate, to have high availability there. So Virt Manager, I think, is sort of more a simplified use case for KVM. Does that answer your question?
Is it likely to look to migrate overt functionality into libvirt and merge them in the future, or are you likely to just keep the overt functionality separate?
I've read that they're implementing a new version of VDSM, which actually it uses, I think, I'm pretty sure it uses I can't remember now, but basically they're looking at implementing a new version of ovirt as a library so that other, such as Cloud, what was it, CloudStack? Yeah, such as the CloudStack could talk directly to the nodes. So yeah, I think there's a move to a newer version of VDSM, more as a library. So probably not in the future. I think that's being developed. Other questions? We had one over here. Yep.
Can you tell us a bit more about performance monitoring tools for ovirt?
The performance monitoring tools.
How do we keep track of the amount of virtual CPUs we allocate, whether we overcommit memory or not?
Yep, that's integrated directly within the web UI within the tabs. So you've got a section for each which displays what's being used. You can also do that for, say, your data centers. You can see, okay, what's happening in each data center. And then in, say, for example, the clusters tab, you can actually see how your hosts are performing with that. So there's tabs for that within the UI. So it's built directly into the UI. Not only that, you've also got statistics collections within the API, so you can actually monitor statistics via the API as well.
Okay, is there any command line tool on the hypervisor itself that would allow me to monitor the research visualization on the part of the hypervisor?
On the hypervisor itself, I'm not too sure